Good day everyone, and welcome to where we are putting together solutions to those math and science problems that students are getting. In this video, we'll be looking at CSEC Mathematics, and specifically the topic of trigonometry, the second question, the one that appears in section 2 of the paper. And we'll be looking at the possible solutions from May 2019 until the present. Feel free to like the video and add any comments down below so we can help create other videos for you that may assist you. Don't forget to take a look at the description down below, where we have outlined the order we suggest to cover the entire CSEC Maths syllabus for you to get a better understanding. Let's look at the 10 major topics in CSEC Mathematics, and in this video we'll be looking at topic number 8, Geometry and Trigonometry. This topic is tested for 8 questions out of the 60 in paper 1, multiple choice, and for 21 marks in paper 2, which is worth 2 full questions. This topic can be subdivided into 2 parts, into geometry or trigonometry. In this video, we'll be looking at trigonometry, so that itself can be subdivided into right angle triangles or any other triangle. Within right angle triangles, we specifically look at that diagram above, where we give the angle, the hypotenuse h, the opposite o, and the adjacent a. And the rules that relate them, we can relate the lengths of all 3 sides using Pythagoras' theorem, which states o squared plus a squared is equal to h squared. Or we can use trigonometric ratios, sine theta is equal to o over h, cos theta is equal to a over h, and tan theta is equal to o over a. Those 4 work for any right angle triangles. And for any triangles, whether they are right angle or not, we can use the sine rule, a over sine a is equal to b over sine b, which is equal to c over sine c. Or we can use the cosine rule, a squared is equal to b squared plus c squared minus 2bc cos a. Let's look at some basic steps we can follow if we're getting problems with this topic. When tackling this topic, the first thing we can do is list all formulae, which are 4 formulas for the right angle triangles and 2 more if it's considered for any other triangle. Then we identify which shape is relevant. We redraw only that shape, and then we identify which sides and angles the question uses, select the formula, substitute, and then solve. May 2019, number 9b. The diagram shows a quadrilateral PQRS where PQ and SR are parallel, and we can see in the diagram those are the 2 horizontal lines, one above and one below. SQ is equal to 8 centimeters as identified. Angle SPQ is equal to 90 degrees, that's the angle up on top, which indicates that the angle below PSR, that's also 90 degrees. Angle SQR is equal to 82 degrees as shown in the diagram, and angle QSR is equal to 30 degrees. Determine, part 1, the length PS. So if you look at PS, that looks like our right angle triangle on the left hand side. And do we know any angles in there? Well, if that angle is 30 degrees in red, then the angle that we have in green there, because the total is 90 degrees, they are complementary, that angle will be 60 degrees. So if we extract that and we look at that right angle triangle, we want to find PS, which is the adjacent, and we have 8 centimeters, which is the hypotenuse. So that will use our trigonometric ratio cosine theta. So let's write the formula. Cos theta is equal to a over h, and let's substitute. Cos 60 is equal to PS, which is what we want to find, over 8. And if we want PS, the 8 is dividing. When I carry it across, it will multiply. We get 8 cos 60 is equal to PS. And cos 60 is a half. So a half of 8 means that PS is equal to 4 centimeters. And for the second part of the question, determine the length of PQ. So if we look at PQ, using the same right angle triangle, that is the opposite we want to find. And there are at least 2 or 3 different ways we can solve this. So we have opposite and we have hypotenuse, so let's use sine theta. So let's write the formula. Sine theta is equal to opposite of hypotenuse, and we can substitute. Sine 60 is equal to PQ, which is the opposite, which is what we want to find, over 8. So if you want PQ, it will be 8 sine 60, 8 times sine 60, which works out to be 6.9 centimeters. So we found the length of one parallel side, PQ, and we found the perpendicular distance between both sides. May 2019, number 9B, part 3, the last part of the question. Determine the area of PQRS, that is the quadrilateral. And there's a formula given in the formula sheet for area of a quadrilateral, which is a half A plus B times H, where A and B are the parallel sides, and H is the perpendicular height, or perpendicular distance between them. We know H, that's 4 centimeters. We know A, or one of the parallel sides, 6.9 centimeters, which we worked out before, those two things in part 1 and 2. And we need to get the distance RS. We need to first find the third angle that's missing in that triangle, so let's extract it. And if we have 82 and 30, remember that if we add up all three angles in a triangle, angle S plus angle Q plus angle R, it will give us 180 degrees. And we know two of the angles. So 30 plus 82 plus R is equal to 180. 30 plus 82 is equal to 112 degrees plus R is equal to 180. So R is equal to 180 minus 112. So the angle R is 68 degrees. So if we bring up 68 degrees here, we should now be able to solve for RS. Because we have 82 degrees, that's Q, and we want to find RS, the opposite sided. We have 8 centimeters and we have 68 degrees. So we can use the sine rule. Q over sine Q is equal to R over sine R, and RS over sine 82 is equal to 8 over sine 68. So if we want RS, then that will be 8 times sine 82 all over sine 68, which works out to be 8.5 cm. So we can now substitute that. Let's bring it up into our diagram. 8.5 centimeters. And we can now substitute area of PQRS equal to half times the two parallel sides A and B, which is 6.9 centimeters plus 8.5 cm, times the perpendicular height, which is 4. And that, when we substitute that into our calculator, it gives us 30.8 centimeters squared. So that's the area of PQRS. May 2021, number 9B. From a harbor, H, the bearing of two ships, Q and R, are 69 degrees and 151 degrees respectively. Q is 175 kilometers from H, while R is 242 kilometers from H. Part 1. Complete the diagram above to show the information given. So we already have 69 degrees, and we want to show the other bearing, 151 degrees. And that means that we're standing at harbor H, and we're looking up in a northerly direction, and we're turning in a clockwise direction until we face R. So let's bring up that angle in red, and that entire angle is 151 degrees. And we already have a distance of 242 kilometers from H to R, but we did not insert the distance from H to Q, which is 175 kilometers. Part 2. Calculate QR, the distance between the two ships, to the nearest kilometer. If we extract that triangle HQR, and let's identify by putting a purple arrow to show what we want to find, QR, that length, we know 175 kilometers, we know 242 kilometers, we want to find a third side, and we have the angle in there. And what's the angle? Let's see if we could solve that. The angle NHQ, which we have in black, plus the angle in purple, angle QHR. When we add up those two things, it gives us the entire angle NHR. And we have two of those, so 69 degrees plus angle QHR, which is what we want to find for this triangle, is equal to 151 degrees. So QHR is equal to 151 minus 69, which it works out to be 82 degrees. So we can now place that into the triangle. So we have two sides and an angle. We want to find the third side. That means we can use the cosine rule. So let's write the cosine rule. A squared is equal to b squared plus c squared minus 2bc cos A. And if we substitute, what we want to find is QR, which is opposite to the angle that we have. So we could use QR as A. So QR squared is equal to HQ squared plus HR squared minus 2 by HQ by HR cos H. If we substitute, we're going to get QR squared is equal to 175 squared plus 242 squared minus 2 times 175 times 242 cos 82. And if we work out the first part, that's going to give us 58,564 minus 2 times 175 times 242 is 115,325 cos 82. And put that into our calculators, that's going to give us 42,514. So if you want QR alone, we get rid of the square from the left-hand side, we carry it across, will be square root of 42,514. So QR is equal to 206 kilometers. May 2021, number 9B, part 3. Calculate how far due south is ship R of the harbor H. So let's extract the diagram and let's look at where north is, and let's try to draw a line from H going across to the east, to the right, which would therefore there will be a 90 degrees there between north and east, and then turn south and head to R. So there will be a 90 degrees in green there as well. And we know that entire angle, that bearing was 151 degrees when we were standing at H and turning until we faced R. And part of that is 90 degrees. So the remainder we have in a black arc, and that will be 151 degrees minus 90 degrees, which gives us 61 degrees. So we have a right angle triangle with two angles and a length of 242 kilometers. And we want to find the opposite. So O and H means we can use sine theta is O over H. So sine 61 is equal to O over 242. O being the opposite, meaning how far due south it is, R from H. So if you want O, 242 sine 61, which works out to be 211.7 kilometers. May 2022, number 9B. From a port L, ship R is 250 kilometers on a bearing of 065 degrees. Ship T is 180 kilometers from L on a bearing of 148 degrees. This information is illustrated in the diagram. Part 1. Complete the diagram above by inserting the value of angle RLT. So RLT is that triangle, so let's extract it. And what do we know? We know the entire bearing is 148 degrees if we're facing north and we're turning until we're facing T. So we have that in red. And we know 65 degrees is the bearing from L to R. So we have that in purple. As such, if we want to find angle RLT, that will be, let's represent that by a black arc. So angle RLT, which is in black, will be the angle in red, angle NLT, the whole angle, minus the angle in purple, angle NLR. So if we substitute, that will give us 148 degrees minus 65 degrees, which works out to be 83 degrees. So let's bring that up in the diagram. Part 2. Calculate RT, the distance between the two ships. So let's show that distance with a purple arrow. And what do we know? We know two sides, and we want to find a third side, and we have an angle. So 3 sides and an angle means we can use the cosine rule. So let's substitute. A squared is equal to b squared plus c squared minus 2bc cos a. And what we want to find is RT. And we know the angle opposite that. So RT squared is equal to LR squared plus LT squared minus 2 by LR LT cos L. We can substitute 250 squared plus 180 squared minus 2 times 250 times 180 cos 83. And we could work them out the entire thing one time, or we could work them out in parts. So 250 squared plus 180 squared is 94,900 minus 2 times 250 times 180, which is 90,000 cos 83. And if we substitute into our calculators, that will give us 83,932. So if we want RT, RT is the square root of that, which gives us 289.7 kilometers. So we found the distance between R and T. May 2022, number 9B, part 3. Determine the bearing of T from R. So that means we're standing at R facing north and we want to turn until we face T. So let's extract that point R and let's put a north line on it in black. And if we're turning in a clockwise direction, we'll be turning along a green arc until we're facing the direction of T. Now, if we recognize that the entire thing gives us a complete circle and is broken up into three parts: the angle in green, which is our bearing, plus the angle in red, which is angle LRT, and angle LRN, which is in purple. So if we know two of them, if we work out the angle in red and the angle in purple, we'll be able to solve for the bearing. So let's see if we could work out the angle in purple first, LRN. So let's extract from the diagram L and R, and let's put a north line on both of them. So we have two parallel lines with a transversal. And we know 65 degrees, that was given. And if we have 65 degrees, can we find the other angle, the one in purple, LRN? The two angles are interior angles, meaning they add up to 180 degrees. So if one angle is 65 degrees, the other angle will be 115 degrees. So we found LRN, so you could substitute that, 115 degrees. So we only need LRT. So let's see if we could work that out. Look on the big diagram. We have the angle in red, LRT, which we want to find. And we know opposite that, the length is 180 kilometers. We know 83 degrees, and we know 289.7 kilometers. So we have two sides and two angles. We can use the sine rule. R on sine R is equal to L on sine L. And we want to find an angle, so we could flip both sides. So sine R, and R is really LRT, that angle in red, over LT, that distance, is equal to sine L over RT. And if we substitute, sine LRT is equal to 1 over 180 is equal to sine 83 over 289.7. So if you want sine LRT, we could carry the 180 across. So that will give us 180 times sine 83 all over 289.7. And that works out to be 0.617. And if we want LRT, we carry the sine across. So sine inverse of 0.617 is 38 degrees. So we can now substitute for LRT as 38 degrees in our second line on the left. So what we have is the bearing, which is in green, which is what we want to find, plus 38 degrees, which is in red, plus 115 degrees, which is in purple, is equal to 360 degrees. So we can solve the bearing, which plus 153 degrees is equal to 360. So if we carry the 360 across and subtract, means the bearing of T from R is 207 degrees. This brings us to the end of CSEC past paper questions in the topic of trigonometry, specifically in section 2 of the paper 2. In our first video, we looked at May 2009 until 2013, and our second video, 2014 until 2018, and this video, 2019 until the present. Our next video will look at other topics in CSEC Math. Don't forget to look at the description down below, so you can get an overview of all our playlists in all the different topics.